have the Arduino here, and I got the code pulled up over here. So the project can do various things. If we want to select an option, all we got to do is set the condition for, which script to run essentially. So right now I have support for 12 options. You can see that it goes red when we go beyond that. Let's say you're really lazy or just can't even be bothered to set the settings for your game. You just want to be playing the game right now. You don't want to be on the menu. Well, we got a solution here. Option 8 is called single player selection. So if we click that option here, it'll control the Arduino, will automatically pair itself, and then it'll go through the menu process for us, and then it'll come out to pair back to the controller, so we can use our controller as we normally would. So right now it's randomly picking the kart combination here, and it's showing us our stats too. So of course you could do this with the screen being off. If you're really lazy and you can't even be bothered to look at what it's doing, it'll just do it for you. Now it's gonna go through and pick some random items for us. So it's using an array structure, a two-dimensional array, figure out what items it's already clicked and what items it hasn't. So it's just gonna randomly select some items for us. And once that's done, it's gonna randomly pick a course for us. And we got Mount Wario. It's gonna go into the game, and then after a few seconds here, it'll jump back to the player pairing screen so that it can connect our controller back. And there it goes. So now we can just connect our controller back, and we're paired up. We can go to the game and we can start playing. Now let's say we want to do something a bit more nefarious. Say we have a friend over and he's just upset us, or we just want to ruin his day for whatever reason. Well, we got an option here called automatically close game. So let's say our friend's just over here casually playing his game. All we got to do is plug in this Arduino into the switch. Now all we need to do is pick option 12, ruin our friend's day. So if we go over here, go to option 12, click on that, gives us a few seconds to run away so our friend doesn't notice. And there you go. You've just ruined your friend's day. Don't blame me if a controller gets thrown at the TV. If you want to be really nefarious, you could set this up so that when you plug in the Arduino, it resets the entire switch, so your friend will lose literally everything on his switch. Might be kind of harsh, might be kind of funny. Don't blame me if you get knocked out though. So for a little rundown of all the different components we have here, so we have, these are our analog signals. So right now I have 2 joysticks hooked up for that. So one of those is for controlling the switch, while the other one is for controlling the script menu. Then we have over here, we have a little push button. So that's used for, it's just really used as a button for the Nintendo Switch. And then over here, we have a touch button sensor. This one can be used for the Nintendo Switch, and it's also used for going in between different submenus in the scripting. Now this right here is a little Bluetooth controller. So this transmits and receives serial Bluetooth. It can be used as both a master and a slave. It is known as an HC05 module. So this is our 7-segment display. It depicts all the scripting numbers, and then similar to that, we have the RGB stick. This shows the progress in the script. It also gives us errors in the form of turning red, and then it can turn green when something was successful, or it can turn yellow when there's needed input as well. And then the way I have everything wired up here, I have a Grove base shield, so that kind of just attaches via pins to the Arduino, and then we have the 4-pin connectors that connect to the various inputs and outputs. Now let's say one of these connectors up close. So you can see that we have 4 wires here, a yellow, white, black, and red. Now if we look over here, let's say we're looking at the analog stick. The analog stick has an X and Y input. So if we look right there, we can see an X and a Y input, as well as the VCC, which is our power, and the G and D, which is our ground. So if we look over here at the base shield, we can see here we have ground is our black wire, red is our power, A1 is translated to our Y value, and then the yellow wire becomes our X value. And then when we push the button down, like say we push the button down, that transmits a really large signal to the X value so that we know the button's been pressed. And now for something a little more simple, like say this push button here, we have an NC connector, which essentially means not connected, and then we have a signal connector. So essentially the white wire goes nowhere. The yellow wire is our actual signal. So if we look over here, we see that D2 is our actual signal. Well, D3 isn't used, which means we can use D3 for something else. So in this case, I have the D3 line hooked up to this other button. And the way we interact with it in the code is these numbers correlate with the data lines we use as the pin IO. So for something more complicated like this clock, we will need 2 signals, but this time we have a digital input output signal and a clock signal. So white is our digital input out, which is going to be our D5 line, while our clock is going to be D4. And then there's a library that was provided when I got this module that basically gives you an easy way to set up a class object for this guy. So the main code was written in the Arduino IDE, specifically 1.8.18, because Arduino 2 was not working properly with this library. So Nintendo Switch library is the main library I'm using. So that kind of lets you read the Nintendo inputs, and like we can look down here, kind of examples like push button, that'll push the home button, push button A, that'll push the A button, and then it'll have a 500 millisecond delay. So if we look in the code, we've included that library, which again is that GitHub profile. As for getting the Switch to understand the Arduino as a controller, that was done editing the boards.txt file, which is essentially the firmware for the Arduino. So I did have to edit that. I'll try and find the exact lines I changed. Alright, so this was the original guide I found for connecting the Arduino as a Nintendo Switch controller, and I will have this linked in my GitHub repository, which is Mario Kart script under my username. But essentially, we need the Arduino AVR boards. We need to edit the board's TXT file and change the following so the firmware is seen by the Nintendo Switch. And then you need the Nintendo Switch control library, which is this right here for character selection. It's just basically picking a bunch of random numbers and then selecting a character. Cart selection, really, it's the same idea. Item selection, that's a bit more complicated because we have two-dimensional board, which is the various items, and we have to pick various items. So I essentially have a visited list and we'll update with a 1 for any item we find. Now, of course, the square you start at is not guaranteed every time you run through the menu. So I account for that because we always know that the square will be at the bottom, and since when you go left it overlaps to the right, and when you go right it overlaps to the left, we never have to worry about this code going off the grid, essentially. If you want to learn more, I'd suggest just checking out my GitHub repository. I do have future plans for integrating this with a Raspberry Pi, and to do that, currently there is an NXBT project, and this one provides kind of a Python interpretation of this Arduino Nintendo Switch control library, and it allows you to control the Switch via Python.